one. Okay, we are going to do our review for functions. So I'm going to do a mixture of different problems and hopefully that will help you. So first of all here, we are given some input and output values of a function. Actually, we want to know, do those represent a function, right? So if we want to know if this is a function, we're focusing on the x values only, the input, right? And the input cannot repeat. So we could not have this two different input for the same y value. So we're going to negative 10, 4, 0, 3, 4. No x repeat, therefore this is a function. So we're going to say function because no input value is repeated or used twice. Okay, this, I don't know if that's the best 10, so let's see if I can find another one. I want to go to, well, let's do number 2. The hours you stay awake is a function of the number of Monster drink you have in the evening. And we want to know which one is the independent and which one is the dependent variable. Let's see if I can make that focus better, maybe a little. Okay, so your keywords here are is a function of. Is a function of. So recall that when you read a function, you say f of x, right? That means that the x inside is your input, your independent variable. So when you're reading this, which one will be your independent variable? That's what we want to know here first. So we're saying that the hours you are awake is a function of the number of Monster drinks. So of the number of Monster drinks, that will be your independent variable. So the independent variable will be the number of Monster drinks you drink. Hopefully you don't drink any of those anyway because they're not healthy. And then the dependent variable will be the hours you stay awake. Obviously, depending on the most you drink of that energy drink, right, the most you're going to be awake. So the number of hours you're awake is going to depend on how many of those energy drinks you're drinking, and that keeps you awake. Okay, moving on. Use the graph of the right to approximate the following value to the nearest 10. So we're approximating, meaning we probably won't get exact value. We probably have to kind of make a very, you know, an approximation, an estimation. An educated guess was what I was looking for. So f of 5, so I'm looking, 5 is here, and f of 5, well, here I don't have to make an educated guess because it's pretty obvious that f of 5 would be 1, right? So f of 5 equals 1. F of 0, well, okay, so 0 is here, so the y value will be down here. And again, I don't need to estimate here because f of 0 will be negative 4. Now, I want, if f of x equals 5, what is x, right? So here I'm given the output value, meaning that's my y value. And I'm looking for the x. I want to know what is the x value, right? The y. So for an output of 5, that will be on the y-axis, what is my x value? So that will be my point right here. So I'm going to say, okay, what will be that x right there? And that will be 3. So if f of x equals 5, then x has to be equal to 3. If f of x is 0, so again, this here is my output, my y value, and I want to know what is the x that gives me this y. So a y value of 0 will be right there and right there. I have two of them, right? So a y of 0 will be, and here I have to estimate because those are not exact points. So it will be a little less than 1. So we're going to say x will be about, so we're switching from the equal sign to the about, right? X is about 0. Oh, I don't know, how about 0.75? And here x will be about maybe 5.25. And you could really use anything close to those values, right? As long as you're just a little bit smaller than 1 and maybe a little bit bigger than 5 here. If the dependent variable is the number of kilometers you can drive, and the independent variable is the amount of gas measured in liters in your car, you need to write a sentence explaining the meaning of k of 20 equals 285. So your independent variable, you are told, is the amount of gas measured in liters. Independent variable is the input of the function. Therefore, 20 liters of gas, the output is going to be the dependent variable, and we're told this is the number of kilometers you can drive. So we're going to say with 20 liters of gas, we can drive 285, and it is measured in kilometers. Okay? Now, we need to say if this is a function, so we're going to decide if it's a function, and we have a graph. We do the vertical line test, and as I am sweeping through this circle vertically, I will touch 2 different places on the circle every time I move a little bit, right? So that is definitely not a function. Same here, is this a function or not? So we want to know. I'm going to sweep through, and as I'm sweeping through, I notice that even though my function goes up and down, as I'm sweeping through, I would only touch at one spot everywhere, right, as I'm sweeping through. So this is definitely a function. We're going to say yes. And then what is the function? Well, really, we haven't done those trig functions yet, but I'm just going to tell you, and several of you remember from geometry, that your y-intercept is 1, it's not the origin, so therefore this is not a sine function, it's a cosine function. So this will be the cosine of x. I'm using x as an input because that's what I'm given here. All right. Number 7, identify the domain where the function is increasing, decreasing, and constant. So increasing first, right? We're going to do that first. So as I'm moving, even though this arrow points down, when we're moving and decide for increase, decreasing, we're going from the left toward the right. So even though the arrow points down, as I'm moving toward the right, this graph here, I will be moving up the curve. So that will be increasing. And then it stops increasing because it's going down. So increasing, and that arrow says I'm not stopping, so I'm coming from negative infinity. And it's increasing all the way to here, which is negative 1, 2, 3, 4, 5. So negative 5. So we're going to say increasing from negative infinity all the way to negative 5. And then we have to check if that's the only place. So here we are decreasing, constant, decreasing, but then notice how here at this spot I'm starting to increase again. An arrow means I'm going to keep going. So what is that x value? So this will be 1, 2, 3, 4. So and again I'm going to say increasing again from 4 to infinity. Oh, did you notice what I did here? I put a bracket. Shame on me. We never put bracket with an infinity, right? Always a parenthesis, so I apologize for that. I hope that looks like a parenthesis now, not a bracket, okay? All right, now I'm going to switch colors just so we can see the difference. So decreasing now, well, the function we said stopped increasing here, and then we said it was decreasing all the way to here. I'm going to put that on the other side so I can actually write my numbers down on my x-axis. So it's decreasing, and this here will be negative 2. So it's decreasing from negative 5 all the way to negative 2. And then we have to decide if that's the only place. So then we're constant, and then we're decreasing again, right? Decreasing, decreasing, decreasing all the way to 4, and it starts right there at 1. So decreasing or from 1 to 4. I don't have any infinities here, so I can put my brackets. And then finally, where is the function constant, right? So the function will be constant from here to here. When we go straight through, that will be from -2 to 1. So from -2 all the way to +1. Okay? For number 8, we need to give the domain, and it says interval and inequality notation. That's just to remind you that we can write those in different ways, but on the test I'm only going to ask you to pick one of the two, and I'm actually going to let you pick the notation you like. Here I'm going to do both just as a reminder to help you remember how that goes. Okay, so the interval notation for the domain. So the domain, the point most to the left, right? So we're going to say most to the left, to the right. That's what we want, right? But this is a piecewise function, so we have to include both pieces in our domain, not just one piece. Okay, so it starts at -5 right there. So interval will be from -5, bracket, because this point is definitely in the domain, right? It's a closed interval, a closed dot. It goes all the way to -1, but this is now an open dot, so we go to -1, but with a parentheses because we do not want to include it. And we're going to jump over all the way to x equals 0, and then from 0 to infinity, right, for that little chunk there. So from 0 to infinity, 0 is not included because we have an open dot there, so there we go. And then this in inequality notation will just be my x's have to be greater than or equal to -5, but less than -1, not or equal to, or we want all my x's to be greater than 0, but not or equal to. And now for the range, so remember the range will be your lowest to the highest, right? So the low to high point. And so the lowest will be y equals 0. So from 0, including 0, because even though this one is an open one, we have a closed one here at 0. So we're always going to pick the closed one over the open one. So 0 is included. We go all the way to this point here as a high for that section of the piecewise. So that will be at 2, including it because there is no hole there, so bracket. And again, we are going to start at 3, but this time 3 is not included, so parentheses, and it goes to infinity. And then inequality notation, this one will be now, here we had x's because we talked about the domain. So here we want y's because it's a range. So the inequality will be from 0 to 2. So the y's would have to be greater than or equal to 0, but less than or equal to 2. Or we want the y's to be greater than 3 but not equal to. Okay, so that's for that one. I think that's all we did on this section, so I'm going to move on. Yes, that's all we did on this one. Now on the next one, I'm going to start by doing one first here. So we want f of x equals x over x squared minus 9x, and we have to give the domain. Now remember I told you there are two types of functions where we have to worry about the domain. We have the rational functions, and the rational functions will be the one where we have some kind of function on the top with something in the denominator, right? And then the restriction will be that this thing in the denominator here cannot be 0, okay? That will be your restriction for the rational. And that will be our case right here. And then because we're talking about the restriction for the domain, the other type of functions where you have to worry about something in the domain will be your radical functions. And for the radical, we're going to say even roots, but that's when you have a square root, and whatever is inside, let's call that f, whatever is inside the square root will have to be greater than or equal to 0, okay? So inside the radical, we need something that's positive, therefore greater than or equal to 0. And if we have a fraction, whatever is in the denominator cannot be 0 because we cannot divide by 0. Those are the only two restrictions for the domain, okay? So in our case scenario here, we're going to have a rational function. We have a denominator, and the denominator cannot be 0. So if the denominator cannot be 0, what we do is we just take it. Take that denominator and say, okay, x squared minus 9x, that cannot be 0. And so now solve for x, right? So to solve that for x, this is a quadratic, so I'm going to factor out an x first, right? And then once I factored out this x, I'm just going to solve that like I would normally any other quadratic. So just for now, I'm going to say, okay, what I'm looking for really is I want to know when will that denominator go to 0, question mark, right? What x value would actually make that go to 0, if anything? That's the one I'm looking for, and that's the one I need to exclude from the domain, okay? So we have x equals 0, or x minus 9 equals 0. Therefore, x equals 0 is already solved for x, and this one will be x equals 9. So those are the two numbers, 0 and 9, that would make that denominator go to 0. And if you're not sure, try it. Plug in a 0 for x. 0 squared is 0. Minus 9 times 0 is 0. 0 minus 0 is 0. That will definitely go to 0. And then you will do the same with 9, and you will see that you get 81 minus 81, which is also 0. So those are the two we cannot have in the domain. We have to get them out to make sure this doesn't go to 0. Any other real number is okay, except for those two. So what's the domain? Well, the domain will be from negative infinity to 0, but not including 0. So I don't put a bracket there because I do not want that 0. And then I'm jumping over that 0, and I'm going to start from the other side of it, and I'm going to go all the way to 9, getting 9 out of the domain, so jump over it, do not including, so no bracket, jump over it, go to the other side of it, and now we can go straight to infinity, no problem anymore. So 0 and 9 are the two we're excluding, that will be your domain, okay? So that was for this problem. And now I'm going to switch to the next one, and that was g of x equals square root of 16 minus 4x. And recall I said this is the second type of function that will give you trouble for the denominator, and that's when inside, we call that the radicand cannot be a negative number. So we're going to say, well, okay, 16 minus 4x has to be greater than or equal to 0. That has to happen. So let's solve for x, right? So we're going to say, okay, I'm going to add 4x to both sides. And then I'm going to divide by 4 on both sides. And therefore I have 4 greater than or equal to x. So any x, any number that will be, sorry, I said 4 greater than or equal to x. That means that my x numbers would have to be less than or equal to 4. I hope you made that connection there, because I'm reading that backwards, right? My variable is on the right here. And if you want to read it the other way, you just switch that writing around, and it's the same thing, right? Your small here is still toward your x, just like it was there. So x has to be less than or equal to 4. And so that means that my domain could be any number that will be less than or equal to 4. So the domain will be from negative infinity all the way to 4. Can I include 4? Yes, because it's or equal to. And why can we? Because the radicand could be 0, right? Because the square root of 0 is just a 0. So as long as this is not in a denominator, we will be okay by setting it equal to 0. Okay, so that was our number 2 on unit 3, review. And I think I'm ready to switch to my paper. I couldn't do it on my paper because I already had some things written down, but now I think I can switch to the paper. So here we go. So I'm going to H now. This has a square root on the top and it has a rational at the bottom. So the rational function, the denominator cannot be 0. So t minus 5 cannot be 0, therefore t cannot be 5. The numerator has a square root, therefore the radicand t plus 3 has to be greater than or equal to 0. Therefore t plus 3 greater than or equal to 0, t has to be greater than or equal to negative 3, right? And so now if I put all of that together for my domain, I have t has to be greater than or equal to negative 3, and it cannot be 5. So if you need a visual, put that on a number line. So you're coming here from negative infinity to infinity. Something happens at negative 3, something happens at 5. And so now we wonder, t can be anything greater than or equal to negative 3. So negative 3 is in, and anything greater than that. So I'm going to go towards this side. I don't want anything less than negative 3. However, I cannot have 5. So I need a bubble there. Bubble. So I'm going to 5, jump over it, and then include the rest of it all the way to infinity. So what does that mean? That just means that my domain will be from negative 3, and I'm going to include it, right, because it's or equal to, all the way to 5, but I'm not including 5, so parentheses, jump over it, start on the other side of it, and now we can straight go to infinity without any issues anymore. All right, next one. We need to, so we are given a function here, and we need to give the domain and a few characteristics. So for this one, I really like to graph it to show you, because we have a multiplication of a radical and an absolute value. So hold on, let me get my calculator. Now I'm going to use my Inspire because that's the calculator I have up here at my desk. But you're welcome to use TI 83 or 84. It's doing the same thing, right? So no issues there. Okay, so I'm going to graph it. And I want to graph the square root of 16 minus x squared, and that technically should be a half circle, right? And I'm getting out of my root, and I want to multiply that by the absolute value, oops, sorry, wrong one, absolute value of x minus 3. Okay, so I'm checking always to make sure I wrote down the correct thing, and I did, so enter. And there is my graph. Now I don't see the whole thing, so I'd like to see the whole thing. So I'm going to move that up some, so maybe go to 10, see if that's enough. Not quite. So let's go 20. Okay, that's enough. So here is what my graph looks like, right? So it's going to be kind of this curve, and then, whoops, that little bitty bump right there. So I'm going to translate that onto my picture here. And to do that properly, I really want a table to have some good points, right? Actually, I would like to know what's my x-intercept here. So 1, 2, 3, it looks like it's at negative 4. So 1, 2, 3, I'm starting right there. Whoa, 1, 2, 3, 4, 5, 6, 7, 8. We are not going to be able to do it if we go by one. So for the y-axis, we are going to have to go 2 by 2. So I need to write that down. So we're going to do 2 by 2, okay? And if you just put the two first one down, that's going to tell the reader who reads your graph, you're moving up 2 by 2. That's enough. You don't have to mark them all down. And now I want to know what is my maximum here. So I'm going to look for my maximum. I want to go somewhere that it's not shiny on my screen here. So my maximum will be, I'm going to go menu, analyze graph, and I want the maximum. So number 3, I'm going to get close, click, scroll over it, and as soon as I pass it, my calculator will tell me what it is, you see. And I'm going to move it to the side a little bit so I can read it better. Here we go. So the maximum will be at negative 2.18. and 17.4. So just past -2. So just on the left of -2. And then 17.4. So 2, 4, 6, 8, 10, 12, 14, 16, 17. I'm going to be off my chart a little bit. And it's going to be somewhere in that area. And then I'm going to come all the way down to x equals 3, and then I have that just little bump here to x equals 4. Okay, so I'm going to grab that. So this will give me that. Then I need to, oh, my y-intercept. What's my y-intercept, by the way? It looks like it would be 12. Okay, so 2, 4, 6, 8, 10, 12. So I need to cross my y-axis right there. And then just do a little bump right here. Here we go. That's how my graph looks like, okay? And I'm going to go ahead and write down my maximum here. I'm going to write it down here because I will need that to decide what my range will be in case they're asking me the range, right? So that would be the point -2.18 and 17.4. Alright, so now we can answer our questions. And the first thing we want is the domain. Well, the domain here was from -4 all the way to 1, 2, 3, that was 4, wasn't it? Yes. So the domain will be from -4 all the way to 4, including those numbers. The absolute maximum minimum values. So absolute means the highest or lowest, right? Not so this here, the little height bump there, that would be a relative maximum, but it is not my absolute. My absolute will be right there. Absolute and minimum, maximum and minimum values, those are your y values, because the y tell you how high or low your function is. So I want my y values. So my absolute max is 17.4. So absolute max is going to be y equals 17.4. And then the absolute minimum will be right there on the x-axis, right? Because it's not going to go below. So the lowest y value would be 0. So minimum will be y equals 0. Now we have that 1, 2, 3 times, right? But it's still going to be the lowest number, absolute. Okay, local extrema, those are not the absolute. So here now I want to know, do I have any other highest or lowest point? Well, right there, that little bump. So now I need my calculator again. And I need to say, okay, now I want this little maximum. So menu 6 to analyze my graph, and then I want another maximum, number 3. But this time, I want that one there, the maximum right there. And see, the calculator tells me, let me move that up a little bit. Here the calculator tells me that this one is at 3.68 and it's 1.07. So here this will be at 3.68 and it's a y value of 1.07. So my local extrema, so it will be a relative or local, same thing. I'm just using the other word just so you make the connection. Those two mean the same thing, relative and local. By the way, what's the other word for absolute? It would be global, right? Same thing. So the relative maximum is y equals 1.07. And then there are no relative minimum because the lowest point everywhere are actually going to be my absolute minimum. Okay? Where is the function increasing? Well, the function is increasing all the way until I reach the max here, right? So when we want increase and decrease, remember we don't talk y's anymore. We talk from what x to what x, right? From what x to what x. So it's from -4 all the way to -2.18. So it's increasing from -4 all the way to -2.18. And is it increasing somewhere else? Yeah, from here to that relative max, right? So this is 3 right there. So again, from 3 to 3.68. And then where is it decreasing? Well, it's decreasing from that x value, which is -2.18, all the way to this one. So decreasing from -2.18. Oh, what am I doing? I missed another. All the way to 3. And again, it is decreasing from this relative max all the way to 4. So from 3.68 all the way to 4. Okay. Left-hand behavior, so as the x go to -infinity, well, that really doesn't happen, right? Because this graph actually stops here and stops here. We're never going to go to the infinity, so it's not applicable. So we're going to just skip that. All right, now we're going to evaluate some piecewise functions. Actually, I think this video is long enough, so I think I'm going to do another one. So this is already 30 minutes here. So let's do a second section.